Welcome to Chapter 3, Section 1, Congruent Figures. In this section, we're going to understand the concept of congruent figures, and we're going to accurately identify the corresponding parts of figures. Real quick, before we get started here, I want to give you a short reminder that when I switch pages, it may be advantageous to you to pause the video, copy down the figures and the definitions that I have on the page, and then when you're ready, press play and listen to my explanation. So congruent figures are two figures that have the same size and shape. This is important. They need to have both the same size and shape. If they just have one or the other, no go. Have to have both same size and shape. And the important part about congruent figures is that corresponding parts of congruent figures are congruent. Okay, and we'll talk about what the corresponding parts are in a moment. But this is what we're going to focus on in these next few chapters, are congruent figures and primarily congruent triangles. So let's take a look at congruent triangles. All the corresponding parts of congruent triangles are congruent. Okay, now let's just ignore these things over here on the side. Let's take a look at this first. I'm telling you triangle GEO is congruent to triangle FUN. Now, you know that you can name this triangle over here GEO or GOE or EGO, all different names. Now, it doesn't matter which name you use. However, once you pick a name for the first one, that dictates what the name for the second one is going to be, because you have to line up the corresponding vertices. Now, what do I mean by corresponding vertices? What I mean is that by telling you that triangle GEO is congruent to triangle FUN, G corresponds with F, and E corresponds with U, and O corresponds with N. What that means is G, the point G on the first triangle, is just like the point F in the second triangle. Point E is just like U, point O is just like N. Alright, so it's kind of like our roadmap here for our two congruent triangles or congruent figures. The corresponding vertices tell us the corresponding points on the figure. Okay, now just by looking at this, we can already identify, well, if this is true, then angle at G is going to be the same as the angle at F. So we can say that angle G is congruent to angle F, and the angle at E is going to be congruent to the angle at U. So angle E is congruent to angle U, and the angle at O is congruent to the angle at N. And then we can use the same logic to look at the segments. That, well, segment between G and E is going to be congruent to the segment between F and U. And the segment between E and O is going to be congruent to the segment between U and N. And the segment between O and G is going to be congruent to the segment between N and F. So with a triangle, we have 6 statements we can make with congruent triangles. So if I tell you that two triangles are congruent, you can immediately state 6 different statements based on 3 angles, 3 segments. Now let's take a moment, take a look at this figure, copy these things down, and then I want you to make marks on the diagram by what's given here, that M and N are midpoints and these segments and angles are congruent. And then I want you to see, why can you conclude these statements A through D here. So make your marks, make your conclusions, and state why you can make those conclusions. So pause the video, copy it down, do those things real quick. Okay, hopefully you had a moment to copy the figure down, make your marks, and state your reasons why you can make these claims here below. But let's talk through these together here. Now, we want to know, is angle ADC congruent to angle ABC? So we're talking about this angle right here and this angle right here. Well, hopefully you made marks that, well, 1 and 4 are congruent and 2 and 3 are congruent. So we can conclude that these are going to be congruent through addition. Alright, and then CM and AN, so we want to know AN right here, this segment, and CM, that segment. Are they going to be congruent? Well, we know these big segments, DC and AB, are congruent, and M and N are both midpoints. So if we have 2 segments are congruent, put in midpoints, their pieces are going to be congruent by division. And then DC and DB, well, we know DC is congruent to AB, AB is congruent to DB, so we can do a little switcheroo here, and by the transitive property, we know that DC is congruent to DB. Now, I'm curious to see what your opinion was on part D here, because this is actually a postulate that we have yet to cover. And however, it should make intuitive sense that, well, BD is congruent to DB. So from B to D, that has to be congruent as from D to B. And so if you think about it, well, the distance between B and D should be the same as the distance between D and B. So we call that property, this is a postulate, the reflexive property. Okay? It's a postulate stating that all segments are congruent to themselves, or all angles are congruent to themselves. So it's just the reflexive property. A is equal to A, B is equal to B, so on and so forth. Okay, let's try this again. Let's take a look at one more example here, and I want you to copy down the figures once again, copy down the given, make your marks, and take a look at why you can say all of these statements. Okay, hopefully you had enough time to write down the diagram, write down the given information, and come up with your own reason for why you can make these statements. So first off, part A, we have angle QFG is congruent to angle RGF. So QFG, we're talking this angle right here, and RGF, or this angle right here. Now, what do we know about angles 7, 8, 5, and 6? Well, we do know that 7 and 8 are congruent because we have a bisector, and we do know that 5 and 6 are congruent because we have a bisector, but more importantly, we know 5 and 7 are congruent. So if we have pieces or half angles congruent, then whole angles are going to be congruent by multiplication. Okay, so by multiplication, we can say that part A is true. Now, part B, once again, QP and QR, we want these little pieces. Well, we know that these big segments, QG and FR are congruent. We know these smaller segments, PF and PG, are congruent. So we can say that this is true by subtraction. Now, why can we say that angle 7 is acute? We know angle 5 is acute, and we know 5 and 7 are congruent. So by the rule of substitution, we can say that angle 7 is acute. And finally, angle FER is congruent to angle GEQ. So I want you to picture this for a second. FER, okay? So FER, we're talking about this angle right here, okay? And then GEQ, well, isn't that the same angle? And so, yes, it is the same angle. So what do we say? We say that this is true by the reflexive postulate. The reflexive postulate tells us that this is okay. This is good to go. All right, so your assignment tonight, before you come into class tomorrow, I want you to look on page 114, complete 1 to 4, and then 5 just part A. You only need to do part A on number 5. Come in with your questions, have these done, and we will do some more tomorrow.